Okay. Can you guys see the screen now? Is that okay?
Buen día. ¿Te puedes hablar a César que ya está conectado, ya está funcionando el link?
I think I see the screen.
Yes, we can see the screen. We can see the screen.
Okay,
Okay,
okay.
good.
Thank you. Okay. So yeah, in last room we talk about if we add the CP100, we can find this a smoother coin in this place. So if we don't, it just shows like this. Okay. The movement will be smoother after setting the CP, and the beat could be promoted as well, as you can see here. And here is the use of think. So after we run in script, the yellow cursor on the host computer indicates that the screen runs, and the green cursor indicates that the robot runs. So in most cases, there's two out of sync. There's a screen running ahead of the robot. Like these examples, we can see the move P1 is moved to the grabbing position, and then we type a do one on is clapped object. After this, we type wait 100. It just means hold still for 100 milliseconds. And then after this, we move to point 2, lift, and then the local is grabbed. For the BI, is detect if the object is in position. Okay, so okay, yeah. And then after aboving screen started to run, we will set it to the last line and return in script value of 0 very soon. So at this time, the robot may still be on the way to P1. So in fact, the desired effect is that the script needs to be wait for the robots to each P2. So let's watch these examples. Like the first is move P1. It means move to the grabbing position. And then also like this, we type the do one on is clap the object. We wait for 100 milliseconds and then move to point 2. Lift, we add a sync is synchronization, it's script waiting for the robot to each P2. And then it's like this, local is grabbed. Detect if the object is in position. And also guys, if you want this, watch this PowerPoint more detailed, you can send your email on the chatting room and we will send this PowerPoint to you. And then is wait and sleep. Okay, the wait is the delay of the algorithm queue, sorry. And exhausting wait will move a delay command into the algorithm exclusion queue, and it's generally used to delay motion in IO operation. So like this example, we use like move P1, do one on and wait. Just hold still for 100 milliseconds. Next is sleep. It's just interval between two comments, but this will run interval cannot be guaranteed. It just generally use delay the program. So wait is used for the machine's motion delay. The next module is about the control of program follow. So like this picture, the condition, and then if it's a fail, if it's true, the condition code. It's just like a lot of language we use. So it is very easy to understand. Just goes with CR series robots in Lua, which fully supports Lua's native functions, the APIs, the multi-threadings, and other mechanisms. So for the details, if you want to learn more about Lua language, you can remember trying to record this website. You can go to learn more about Lua. Okay, the next is the Lua looping, the looping types. So while you loop, you want to loop the preconditioner is true, and the program will be told execute some statements repeatedly. So check whether the condition is true before you, exhausting the statements. Like for loop, exhausting the specific statements repeatedly. The number of repetition can be adjusted in for loop command. So you can use the repeat the loop until the specific condition is true, and for loop. So this is a loop control statement, the break statement. So if you want to stop the loop or you want to end off the loop, you can use the break statement and to start execute the following script. Okay, so okay, let me see all your questions. Yeah. Other persons use them too. Okay, so if you have questions you want to ask, you can just turn off your microphone and tell me and Joe, and we'll answer you. Or you can just wait for the session end. We have question time. Okay. So there are three new languages. It's the if statements. So it's like most language you learn, if statements consist of booleans expression as a conditional judgment followed by other statements, and if else statements. So the if statements can go on else statements to execute the else statements command when if condition expresses false. And if nested statements, you can use this one or one more if or else if sensitive sentence within an if or else if statements. The condition it fails, it's true condition code. Next is the use of I/O monitoring. So the I/O monitoring is a very important thing. We can use it to view the I/O status and output DO. Okay. And the signal maturity through I/O monitoring interface. Like these during program debugging while one do. Yeah, you can see this very specific example. The program can be executed by the simulating as a DI signal.
As you can see on the right, you can monitor all the DO and DI.
Yeah.
So if you put a while one do, if DI1 equal on, and you can actually check if it's on the right hand I/O monitor board.
Yeah, you can check on this place, right? Okay.
Yeah, that's right.
Yeah. So the next is the collision detecting. So these are 2 points. We have the collision safety function. This is a very special one. So if you turn on this, the machine will immediately stop when it runs to off scale to avoid danger collision. So this is a protect function. It can prevent for a lot of things and accidents, like to provide, the collision detection is divided into 5 levels. So if you do not want to just too sensitive, you can just set the level 1. But if you don't want better operation, you can just to set to level 5, and this will is the most sensitive, and it is really easier to be triggered. Yeah, that's it. So the next
let me sorry interrupt, Jimmy.
Okay.
Let me talk a little bit more about the safety, the collision detection. So some people, can you go back to last slide, please?
Yeah, I mean this line.
Yes. Okay, so some people they set their collision detection on level 5, and when they move without any collision, but it show up, there's a collision warning. So I'm gonna explain a little bit about collision detection. So the method behind the collision detection is all the joint using servo, and servo we use, there's a current go through the servo, right? So if there's a heavy load or there is a collision, that will increase the current go through the coil. I think it's next slide, Jimmy.
Okay.
Not this slide. The slide that show a collision detection. So if you have set the sensitivity on number 5 and have a heavy load and move really fast, that will make the current go. They will make a current go really high. It's like a spurt go up, a spurt go up. So the robot will think that it might be a collision, even though actually it's just a really hard acceleration or deceleration. So to avoid that default alarm, you can either, the correct way is set up your load right. If you have a 5 kilogram load, you gotta tell the robot that we have a 5 kilogram load. Also, to decrease the sensitivity of collision level when it's doing a really fast motion, fast start, fast stop. Yeah, that's something that I want to mention. Okay, that's it.
Okay. So the next is stacking, transporting, palletizing. So this is also divided into task, 4 tasks. Okay.
I think we might have a video about that. Yeah, I think we have a video about that. Jimmy, do you want to play the video or I play the video?
Can you see the video here?
I don't think it doesn't work. I don't think you can click on it, but probably doesn't work on the
see it.
PPT. Okay, it's moving.
Yeah, like this.
So can I play again? It's kind of too fast.
It's a palletizing progress.
Yeah, so now we are available. It's available now for the palletizing solution. We have this demo on this June in Detroit Automate Show, but now is the day that we start to offering this solution.
左立，要不你来讲。
OK， 可以，那我用 share screen 吧。
Okay.
那你那个有人要 mute 的话，你就帮我 mute 了。
Okay. 那我
Okay, so can anyone see my screen?
Yeah, we can see.
Jimmy, can you see my screen?
Yeah, I can see your screen. You can go on.
Cool. Okay. Any question, you can turn on your mic or type on the chat. You can turn on the mic and talk to me directly because we have a lot of time. Stop me anytime. Okay, let's talk about the learning tasks of the stack transportation palletizing. So well, for this one, let me talk about a little bit about the size of an effector. If anyone want to design your own tool, you need this 2D drawing. You gotta know the screw hole of our robot, the end effector is pretty standard. But yeah, feel free to ask us if you need it. If you buy anything from on robot or our gripper, our hole is standard, so it's always gonna fit if it's a standard gripper. So this is the 2D drawing. Okay. and this is the I/O. This I/O is have a RS485 communication, and it support the N terminal of the CR product, and the product is NPN. This is important. It's NPN. If if you have something is PNP, that means that you might need a relay to, transfer NPN to PNP. And this is all the wire you can see. We have 1 to A, which is white brown is 485 AB, and 2 digital input DI1, DI2, digital output DO1, DO2, and ground and 24 volt. So this is for easy to use. That we have a port on the N effector, but you always can plug this in to your computer, to back of the controller. And this is all the gripper that we support. We support 2 F85 and PGC. I think this is all PGC, and this is Robotech. This is our 6-degree force sensor, Conway. Okay, let's talk about how to use them. After you plug this in and how you use them, we have this. We have a plugin called Dobot Plus. It's integrated with our software. After you plug in, you can click the Dobot Plus on the right-hand side and select. For example, now I'm plugging Robotech, a Robotech 2 F85 gripper, right? So I just pick this one. Pick this one and install it, and you add a few more commands for specific gripper or specific tool. Okay, for example, now I pick this one. This one is called Robotech Epic. It's really common gripper. After I select that, I can go to setting, initialize it, and if I click control, okay, I can set up the maximum level. If I want to open the gripper all the way, when I click open, or when I click close, I want to close halfway or all the ways, or how many percentage, whatever you like. So you can do the setting here. After you set it up, and every time you click close, it's going to go to minimum. Open is going to be maximum. So you can change all the setting here. It's going to be much easier. We have that. And for our suction cup control interface, it's figured the user can control the suction cup by setting up, and the shortcut key. This is all the shortcut key. Only if the N effector has been adapted, we can realize the N shortcut key controller, which is mean that if your tool is compatible with our robot, you can pair with our button on the N effector. So you can click the N effector button to control the gripper open and close, but it only the one that we support. Now we support on robot DH and Robotech and all that. We have a list. You can see on our website. Okay, let's talk about script programming control. Script programming control. Now, how do we do the pick, initialize the gripper, start up gripper, and turn off the gripper? Okay, what is the difference between this and that? The difference is we are trying the same thing. The same stuff is we're trying to do the same. We're trying to control the N effector, but in different language. This one we control it by this like a puzzle. We call it broccoli. Call it broccoli. It's like puzzle. I call it puzzle. Right? You put it together, like an image. Broccoli. But for old-fashioned, people use programming. They just write a script, they type it. So if you want to type it, instead of initialize just by click here, initialize here, how can we do it on script? So on here, it's going to show you. If you want to initialize it, you type this RIP epic initialize. So you type it here, then you initialize, same thing. So if you want to start it, you type this, use RIP epic grip. If you want to turn it on or turn it off, you type it this here. So this is the sample. To initialize it, wait 1 second, and then start the gripper, and then turn off the gripper. Okay, so this is a sample. Okay, let's talk about this thing. Let's see. Talk about simple transporting of the stack. What is this? So transport the 4 stack to the corresponding area using the robot and the suction cup. So if you want to, this is the stack area, stack 1, 2, 3, 4, and you want to put it to a corresponding area, which is here, stack 1 placement, stack 2 placement area, stack 3, stack 4. This is the program that you use. After we share this PowerPoint to you, you can copy and paste or take a look of it. So basically, they take this and put it here, and this is a metric. So now you can program yourself, and this is just a demo. Okay, let's see if there's any question. Page 33, 77 of Harvard user manual. Okay, so for this question, please email us. Please email us this question. And Jimmy, can you please help me type our email address on the chatting, because we need to double check on your question.
Okay, yeah.
Okay, let's go.
I think your screen is.
Okay, I think I just lost a little bit. Am I back? Can anyone hear me well?
Yeah, you're back, and we can all hear you.
Yeah, we can
go
hear
on.
you.
Yeah.
Okay, so for jump is specific design for pick and place. You pick somewhere A from point A, and then move and to B. People can use linear motion. You can just program it A to B and B to C, C to D. But also you can just use our command jump and to just do this whole thing in one command. And you got to set up different height, which is here, number 1, and width, number 3, and then when you jump, number 5. This is jump. And also it's really important to look at the number 2 and 4. This is also for optimization. When you start your project, you can make the robot slow, right? You can test it slower. It's okay, just be safe, pick something up and move and drop it. But after you already figure out the whole process, you want to make your beat faster, right? You want to pick and place, optimize from 5 seconds to 2 seconds. And how you do? You can optimize on here. If you make the turn, Jimmy, can you help me to mute some? Yes, thanks. You want to make a turn so it won't stop, right? You don't want to stop every time you change your direction. You got to either add the command CP, you can put CP there to make it go around it. Or you can use this function here, You can see it on here when you go to jump. This one of the dimension is how rounded you want when you turn the corner. Oops. Yeah, it's not showing here, but this one important way to make the speed of the robot faster is don't let the arm stop when you turn in the corner. Okay, let's show you a video. Let's show you guys a video. Okay, I hope anyone can see it. So this is the program. So we take the palette. This is 2 by 1, 2, 3, 4. 2 by 4 by 1. It's only one layer. And we take one here and put it there. Okay, to see if anybody have a question. Okay. And also you can see when you're running a program, you can see that each line, is moving from this line to this line. It's moving, which is great. Sometimes if it's stuck there, then you know that, okay, something wrong, the program stuck there. Okay, see now you can program it to 2 by 3 by 2 or something like that. It's up to you. It's anything that you like. This is palletizing. We just use this as demo, but now our palletized solution is available, which is this one. It's available, and it's a funny thing. This on June, I set this up. In Auto Show. Yeah. So this one is the whole solution. It comes with PLC. It comes with PLC. It comes with all the sensor and everything. And for this one is we just you kind of do it yourself kind of thing. Kind of do it yourself, all written in program. There's no monitor. You can do the setting by simply touching it, and there's no PLC, definitely no sensor. You gotta put some sensor there to sense if the pallet is actually in place and all that. Okay, this is the method behind it. You gotta set up the stack. You gotta tell the robot this is what 4, 1, 2, 3, 4, 4 by 2. And if there's a layer and then we want to put it here, this is 2 layer. And this is our built-in software. When you use it, this is on the process. When you click on it, you can set up the point A, point B, point C. What is that mean is point C is when you're actually suction cup touching the part. That's the point C. Point A is when it's approaching the package. Point A is the safe point. So you want every time the robot go to point A, it's not going to knock down anything. It's not going to be knock down everything. It's going to be a safe point. So this is point A. And point C is when the suction cup touching the package. And point B is the transition point. It's between A and B. So when you set up the process, it's going to be like this. This is the process interface. You set it up on here, and you can see the save point. If you made the robot arm go to the save point, and you can just hit get coordinate, you can just hit this one, and you memorize the coordinate, and then you move, you drag, you can drag, or you can just remote control by using on the panel, you remote control here, and to make the arm go to the prepare point at the first point. First point is when actually touching the box. Okay, that is how this interface setting looks like. And this is the script. So if you not using our whole solution, you're using our process. After you set this up, set up the point, and you also need to write your own program or using our program here, our demo. For this demo, what should we talk about? Okay, there's a few things that I want to talk about. Is unstack is the stack mode value range, and true or false. True is mean unstacking mode. False is mean a stacking mode. And for user frame, the serial number of the user coordinate system used, if it's not set, the default value is 0. And for return is this variable to moving, and it's dislocate that the robot move from the current position to the first target point according to the config stack path. For move out, indicate that the robot move from the current position to the safe transition point according to the configure unstacking path. And yeah, this is pretty much, you can just copy this demo if you're interested on this one. For complex track motion, operating the robot to complete the complex track motion, getting familiar with the use of the robot motional instruction, and the cobot drag and drop teaching function. Learning the mobilization of the track record in script, as well as the use of CR user and tool coordinate. For task 1, complete the track motion through motion command. So how can we use the complex track motion? We have 3 different examples. One is a circle, this one is triangle, this one is a rectangle. Yeah. Okay, so you can do a really simple one is just use go. So you go from point A to point 2, point 3, point 4. You can do this. Or you can use circle, command circle, P19, P20, and 1. 19, 20, and 1. 19 is going to be the middle point between 18 and 20. Okay, and this is going to go 22, 23, and 24. And we have a video. Show some video. Okay, this one is pretty cool. For circle, making circle. Also, you can write your own one, but you can always use our command, which is circle, or you can write your own. Okay, so pretty cool. Let's keep just drawing a circle here. Okay, now
Hello, Joe. Your screen is. I can't hear you now.
Hi, Jimmy. I think you were disconnected when you were just starting slide 39. Can you start over?
Oh, sorry. Let me have a check.
¿Aló? Sí, mi amor.
Sorry, maybe Jimmy
Bueno,
joins.
vaya a clase, no se atrase. Bueno,
His voice is
vaya pues.
freezing, I think.
Ok, mi amor, mañana.
And he's reloading the room. Some problem happened on her room.
establish a user coordinate user2 with the 3-point method. Change the user coordinate of the program from user1 to user2, user1 and user2. So whatever you write your program user1, and you can change a new plane, which is user plane user2, user plane 2, and you can run the same program on this coordinate system. When running the program, the track of the device on two planes are consistent with each other. So for this one, if your program is move from here, oops, I can actually write on here. You made a program run a circle here, right? It's going to be on this plane, and now you switch to user2 plane. It's going to be the same. It's going to write the same circle on here. If you have a new plane, the plane looks like this. It's going to draw a circle here. Okay. For remote control, after complete the debugging on the control software of CR product, select the corresponding remote mode, start plus and stop debugging program through I/O and Modbus communication with no need to run the script through the host computer. A lot of people ask this. Let me talk about a little bit. So if you don't want the robot run, well, you require to have your computer plugged in. Yeah, now you can do it here. What do you mean is, okay, you're supposed to have a next page. Okay, no. Okay, so if you already finished your script, then you can trigger the script by using remote I/O. For example, I plug in DI15, okay, with a button, DI15. So I just need to trigger the script by button. I don't need my computer hooked up to the robot anymore. I just need a button that is connected to IO15. And it's going to remote start my robot by hitting this button. And also I can modify this. And also if you're using this, please update your firmware, to up to date, because if you have some old robot with old firmware, we don't have the function of modify. You got to just use the default port here. For our new one, we can modify them here. Okay. So for remote I/O, for the default one, we have DI11, digital input 11 clean alarm, keep operating, and stop, and remote I/O mode, and emergency stop. And we have a lot of different function here, all the different function. And for the latest firmware, you can modify it. For example, I don't want my start button hooked up to DI15. I want to be DI16. Then I can modify this. Yes. And this is the CR controller IO wiring. And you can download it on our website. It's called Dobot.cc. Yeah. You know, also some people ask us why we are not Dobot.com. Sadly, someone bought this address. But we are trying to buy it back. So now it's Dobot.cc for now. Okay, for if you want to remote control by Modbus, you can select. You have a setting here, and you can pick Modbus, remote control by Modbus, and then you here, you pick the script, and this is the name of the script. This is the name of your script. Oops, name. MAME. Yeah, this is the name of your script, which means that if you change the core register address on here, it's going to start. You're gonna start this script. I'm gonna start this whatever script you pick here. Oops. Okay. And for 0, it means enter remote mode and start operation. 1 is mean suspend operation without exiting remote mode. 2 is mean keep operation. 3 is mean stop operation. 4 is mean emergency stop. 5 is mean clean alarm. And for this one is auto, ready, pause, operating, and alarm. And when remote Modbus, the robot is servo. Be sure of this servo. And the IP is 192.168.5.1. And unless you change it. And this is the tool that we use. But you probably have different tool. For remote Modbus startup, the script running can be done by changing 001 core register. Start with the help of the Modbus port. This is the tool. So we can change the core here to start it. To the remote Modbus script operation status can be viewed by reading 002 describe input register with the help of the Modbus port. Yes, you can change on here, and it's gonna view by reading the 002 input register with the help of Modbus port. Okay. For software information, let's talk about. Oops. How can I? Okay, let's talk about software version. Recently you because due to our fast development, a lot of people we have a small update every 2-3 months and big update every half year, and each update we have a new function or fix some of the bugs. However, if you have any question when you're operating our robot, feel free to email us. Well, we have our email on the chatting room. Please email us. And the best way, the fast way for us to reply to you is you always send, if you're first time asking us, it's best to send your version information here. So under setting on basis, it's going to send all your version information. You know, for this, I know that it's 3.2.8, 3.2a, and the safety IO feedback, because some of the old robot, for example, when it plug into a gripper and the dual plus Robotech doesn't communicate right, it's more than likely it's due to the terminal IO port is out of the day. So if your question come with a screenshot of this page, it's going to be help us faster to identify the problem. Okay. And for this one, the user, which means you guys, can drag a single joint of the robot by unlocking the joint when the device is not enabled. What does it mean is you can drag a single joint if you are not locked the joint. You can drag it. The joint locking function is mainly used to drag the machine to the position through the joint locking. When the robot is enabled in the narrow environment, that may cause the hitting on nearby object. So before you unlock all the joint, please hold the joint, you know, make sure you hold it tight because you just release the brake. For here, you know, funny thing that you can unlock the braking of each joint here. It's under setting, security setting. For example, I want just unlock one joint. The third one, you know, this is the first one, second one, third one. I just click on this. Then I can unlock this joint. For the two center mass, okay, I want to take a break. I want to take a break a little bit. Take a break for 10 minutes, shall we? Okay, so let's take some water. is really important. Some people, some company ask me, oh, why my CR5 always, acting weird, sometimes it act like it trigger the collision detection or something like that. And then when I go looking at their project, I'm asked them, what is your load? They told me that, okay, my load is only like 4.8 kilogram with the gripper. I'm using a CR5. It's supposed to within the load, right? And then I say, oh yes, but is it offset? So that when, and I take a look of it, and the CR5, the maximum load is 5 kilogram, but his gripper was like this. It's like way offset by here, and then it's a gripping a box object here. So then I know that it's already off the limit. So this is really important for anyone who use our robot, and the load is not on this line, it's not on this coordinate. It's not on this coordinate. Then you gotta decrease. You gotta decrease the load. Okay, for this example. So if you lower an object on here, yes, it's going to be 3 kilogram. But if you're going to be offset like that much by 22 centimeter, then the load can only lower it for 1 kilogram. Yeah. So we have a data sheet like this. We have data sheet like this for each robot. For each robot. Okay, this is something that important. Yep, okay. This is important. Because you know that this is like a lever, right? When you learn it physics, it's like lever. It's hard to pick up stop when it's long. Okay, this is CR5. Okay, this is one that I was gonna talk about. He was like picking up stop using a gripper. Then it's like this long. And pick up an object here with 4.7 kilogram. And as shown in the map, that on the position here, it can only support 4 to 3 kilogram. See that? So when you come to picking the product, please look at on the data sheet or request one for us, and we can send to you. Email us here. Yep. And this is our CR10. Same thing. CR16. You can see if it's offset by that much, it only can support up to 2 kilogram. This 2 kilogram is the load. The load is including the gripper, so the total load. Okay. Let's talk about the offset in XYZ direction. So if you are offset here, right? You gotta put in the right diameter on the X direction, Y direction, Z direction. Because if you don't put this right, it's not gonna be balanced. The end effector, it might go off balance. When you unlock it, it might try to lift itself up, to counter resist the weight. But actually there's no weight on there. So this is important. Stop a little bit. Okay, so gotta put the right low and the center offset XYZ and look at the direction. Actually, this is the Y direction. This is the X direction and this is the Z direction. This is a little bit, this is wrong, they mark it wrong. This is the actual Y. Yep, Y, X, Z. Offset in Y, X, Z direction is the mainly set while installing the offset tool according to the tool coordinate 0 direction. The low value must be set if there is a terminal low instead. Okay, adjusting the drag sensitivity can make the dragging more flexible and smoother. This is the setting under security setting, and you can adjust the drag sensitivity. When you drag it, it's going to be harder or easier. You can set up here. In addition to the conventional installation, CR robot also support flip and side installation. You can mount it upside down, sideways on the wall, or custom. But after you do that, you have to go to setting, go to installation, and then security setting, and change it here. Yep, wall, upside down, custom. The rotation angle and indication angle need to be set with different installation method. The user can get the install rotation angle and tilt angle through the interface calibration function. For IP, a lot of people ask us how to set the IP, and you can change the IP here. And for MG400, you only can change the IP lane 2. You only can change the lane 2. One thing, for Wi-Fi module, if you forgot the name of your Wi-Fi, a lot of people does that. If you forgot it, you can, a password, you just cannot find it. So what do? You go to the setting, communication setting, and you can reset your password here. Password. You can reset a password here. Okay, for positive limit alarm. When the joint dragging exceeds the setting range, the limit alarm will be reported. So this is pretty common. Positive limit alarm of the joint. Just drag the joint to the opposite direction. So you can see that, for example, some of them is already exceed the limit. Then you can just drag to the opposite side. You can either drag it to the opposite side or you can just click it. Just click. If it's too big, click the minus. The terminal center point, TCP of the robot, is located in the plane correspond of the J1X and J2X, which will lead to the singularity. So when the bone of the forearm of the robot are in a straight line, it will lead to singularity. What does it mean is when the robot arm is straight up, and it will cause, more than likely, it's going to cause this alarm. To solve this problem, you just need to remote control the arm to a different angle. Change the angle a little bit. Change the angle a little bit. So for example, if this is straight up, and it will have this kind of problem. Okay, so that's other solution. With joint singularity position, if the joint 4 and 6 axes of the robot are parallel, it will resolve a singularity. Yep. So what do you do is just disengage by dragging on the joint, just drag it. The two center point is located in the plane performed by B, joint 1 and joint 2. Here, joint 1, joint 2. Elbow singularity point. So if this arm and this arm is parallel, it will cause a singularity. So don't do that. Because if you want to move this to here like this, it's not possible. Because you gotta move the two different joints, and then the direction it have to be looks like this. So it will cause singularity. It's not possible to move it the way that you describe. And this is other one. X for J4 and J4 and 6. 4 and 6. It's aligned. It will cause that problem too. When the API is programmed incorrectly in the script, an error message will appear. So if there's something wrong with your program, this will pop out. For alarming, when the script is wrong, the point windows will also permit the specific location of the error, which is convincing for us to target the alarm. So when you program it here, you can actually look at on the left. We have a debugging windows. It's going to show what's wrong. And also you can turn on the panel here to track all the points, which is great.
No, ya lo reinicié, ahí sigue como que
Hello,
extraño.
do you have
Me gusta el
question?
sonido.
Now it's question time. Right here.
Sí.
Hi, Juan.
Ah, ya lo puedo escuchar. Pero ¿por qué me parece que el volumen está en cero? No entiendo esa configuración. Ah, ya acabó, changos.
Pero no le habla.
No, sí tenía el volumen bajito, pero lo estaba subiendo acá y no quería subir, no entiendo. No, maldito Windows, no sé cómo que no lo alcanzan.
Okay, I see some question. Okay, about the input and output, are they PMP or MPN about the load? What's about the load? Okay, for the PMP and MPN, it's better that, you know, I reply you on the email. Yes. Do you have protocol to turn off
Hay otra
CR3?
vaina bacana de Ineos Approach, pero
I can find it on here.
era la una
So
la
to
otra.
turn off. Okay, so now you have, this is all the command that you can use for protocols. Let me send this to you. Oh, not here.
Esta vieja se inventó. Yo tengo un alias, yo no me
Which
acordaba.
software is better to program CSS Studio?
Alias.
Okay, so for that, to be honest,
Gallego.
¿Este escribió Camilo o escribió?
I
Ay, ya me
think
lo
that
sabía,
SC
Camilo.
Studio is more stable, but
Ah, pues,
2 months ago we are
No,
transfer
pero Camilo, yo
everything.
digo Camilo Correal de Medellín. Ha dicho
Hey,
lo
Jimmy,
del-
can you help me to
del
mute
No,
the
no, no, esto
people
no.
who's not asking a question?
Es que yo-
Dobot and Alejo, can you mute,
Sí,
please?
pero es que-
Hello. Okay. So for this, for ICE, so SC Studio is more stable because it's the last version. But the unfortunate thing is we are not going to update SC Studio anymore. Every update is going to be on Studio Pro. So I would say start using Studio Pro will be better solution. It will be a better solution. Okay, there's other question. I'm gonna use a translation. Okay, so there's yeah, I'm gonna go back to you for PMP, NPM, NPN, Philip. About the low, what's about the low? Okay. Any question?
I have a question. Well, I don't know if it's possible to run 2 programs at the same time. Let me explain you. We need to detect an object and stop a conveyor, but we don't want to use an extra PLC. So I don't know if we can run 2 programs, one program for the motion of the robot, and another program to detect the object and stop the conveyor. Is it possible?
Okay. You want to use one program to what?
One program to run the robot motion, and other program to detect an object and stop a conveyor. But there are 2 different tasks, but I don't want to use an extra PLC to do that. So I'm asking you if it's possible to run these 2 programs at the same time.
I see. So let me explain to you. We have you can create a sub program here. I don't know if that helps. You can create a sub program here, and inside the sub program you can monitor or outputting IO constantly.
Okay.
Yeah. Do you think that will help you? You know, you can add here. You can see that you can add it here. So you can running the main program and also have a sub program there to monitor
Running at the same
IO.
time. Okay.
Yes.
Okay.
Yeah.
Okay. It works for me. Thank you.
Okay, you're welcome. Okay. Okay, let me talk about this, about the load. Okay, talk about a little bit more about the load. This is kind of important when you buy it. So people ask why the load is decreasing, because it's far away from the arm. Far away from the arm. It's like, let me turn on the camera. Okay, people have a camera. Okay, so the reason is when I picking up stuff, right? When I picking up stuff like this is easier. It's 10 kilogram, looks like this. But if I pick up on the edge, you see, at the edge, the loads on here for my arm is more than 10 kilogram, you know? So if the longer, the more offset for my arm, okay, this is bad angle. The more offset for my arm, then the less strain there is. Yes, that's right. If on the center, no loss. If the load is on the center, then it's no loss. But if it's off the center, then it's going to be decreased. This is off the center. Okay, good. Yes, you can program the CR using Python and MATLAB, but it's gonna be a little bit harder. Let me show you. Let me show you on here. Okay. I'm gonna send you the program here. See that? You can use MATLAB, man-made. Okay, lab. Where is it? Find MATLAB. MATLAB, see that? MATLAB. MATL. MATLAP. MATLAB. But for MATLAB, I gotta be mentioned that for MATLAB is only for our MG400 and Pro 1. You see that? MG400 Pro 1, not CR. Let's see if it supports CR. Yes, this one supports CR. See that? I can send you the link. Let me send you the link. MATLAB, you want to use MATLAB or Python? Python definitely. It support Python. Let me show it to you now here. Okay, for the low, people ask for the low. Okay, let's talk about the low. And see that low on Z direction? See that it's same thing on the graph. If the Z is too far, you see that? If it's 70 centimeter, it's also effect on the graph. You see it here? If you can see it.
Okay.
Yeah. So this graph is here, X, Y direction and Z direction. Okay. Next question. What is the best way to turn off? Okay, the best way to turn off is here. First, you gotta disable on the robot here. And then you power it off. You on the controller, you can just hit the button. You know, first gotta do this first. Disable, disconnect, and hit the power on the controller. Okay. Okay, good. Okay, the jack sensitivity. Well, actually, the jack sensitivity is not as important. Yeah, so the resistance, you can go to security settings, and then you can change the jack mode. And if changed to a small value, it's mean less resistant. If change it to a higher, it's going to be more resistant. So it's higher to resist. If you pull it, you gotta harder. You gotta pull it harder. If you want to push it, you gotta push it harder. It's only effect on the dragging mode though. So normally, if you just control it by here, it's not gonna affect anything. This is only effect you on the drag mode. No, it's not gonna change on the motion. It only change when you drag. Okay, where to find the low charge on our website, or you can email us. You can email us. Ask us for the low charge. Email us. Yep. Where is my, couldn't find it. Find my email. Yep, send us email. Okay, any questions? Also, 我回答了那个。Ask for. Okay, and something I want to ask you guys. For the next training, do you want a training that you and me can talk together? What I'm saying is we program it together. You have your robot and I have mine, and we program at the same time for advanced training. Or you just want us to go through the PowerPoint? Okay, that's great. So you want it, so we program it together. But we just don't know how to make everyone to program at the same time, though. I just still want to figure out. So usually when I was in college, what do our professor do is they want everybody share their desk, and then we program at the same time, and they ask us, but we only have, like, for example, 15-minute practice. After 15 minutes, and we go to next training. So the critical point, I think, is two. One is everybody have to prepare your robot. The second thing is I somehow gotta see your screen, if you have some difficulty on programming. Okay, I will consider that. Okay, next question. Or anything, anyone want to comment on training, how to make our training better. Also, it's great that, today we have like more than 40 people participate here. And people ask a lot of questions. That's better and better. We're gonna getting better and better. Jimmy, looks like there's no more question. We're gonna wait here for like another 10 minutes.
Yeah.
Yeah.
Wait
Okay.
for 10 minutes.
If you want the presentation, send us an email. When will this training be? Where?
Excuse me.
Yes.
I was thinking that for the next time it could also help an example like of a whole implementation. Like, let's imagine we have this workplace and we want to place the robot here. Okay, the first thing we're gonna do is this one, the second one is this one, and we will end up doing this other thing. Like an example.
Yeah. Give me an example.
No, that I mean, an example will be good to show how the phases of the implementation are.
Yeah. So you want an example, and we all do it together, or we just show it to you how to do it?
Yeah, you could show to us how to do it with an example, so that we can then implement it in other place, like mimicking your example.
Yes. These two training, last week and this week is the basic training. For the advanced training, we do have a lot of example. Every
Okay.
application will have an example. But I want to ask you is, do you want us go through the example with you together, you with your robot or I with mine, or you just want it to listen for me
I
to go through it?
I think I just want to listen. I don't have the robot yet.
Okay, got it. Nice talking to you. How can I pronounce your name?
Oh, that's Luigi.
Rigi.
Mhm.
Nice to meet you. Nice to meet you.
Same.
Where are you at?
Argentina.
Argentina. Nice to meet you. Great.
Hi, Joy. Nice to
Yes. Oops. I think. Okay. Anyway. Okay, good. If people who have robot and next for our advanced training, okay, cool. That's good suggestion, Scott. Good suggestion. Sample program to download before training, and we have watched you go through this. Explain to you. Good. So for our advanced training, this is just a basic training. We don't have those, but for advanced training, we will do that. We will do that for advanced. I don't know how to pronounce advanced. ADV. Advanced training. Okay, good. I have a lot of input. Every input from you guys can help us to do better. We have a schedule. Okay, let me stop sharing my screen. When? Good question. Let me find it. My next training is on. Let me check my calendar. Okay, my next training is going to be next week. No, not next week. 17 and 1st. 17. Okay, let me share my screen. 17. Next will be November 17th and December 1st. Yep. And that will be more advanced. So on the November 17th, we are going to talk about the more advanced for example, TCP communication, model bus, and all that. And for the December 1st is going to talk about like conveyor belt, vision kit, and all that. So Okay, for somehow I just lost my connection again. So for November 17th will be about more advanced. For December 1st will be about vision, convener, okay. I think that's it. I think people don't have any more question, Jimmy. And
Yeah.
We're gonna wait here a little bit, and then if you want to take some screenshot or end the recording, we can do it. And after we have to summarize and send it to our group for the review.
Yeah. If you have another question, you can type on the chatting room and we will send it to our team and fix it. Thank you.
Okay. Thank you.
Thank you.
再等等就关就好了，就可以不关就先放在这里。
Yeah.
OK， 先放在这里，然后我就说 Thank you 就好了，放在那里。Thank you everyone.
Thank you everyone. Thank you for your guys' support.
哎，这次还是有点波折的。还有另一个的就是下次我看了一下我们的那个，下次就没那么简单了，可能就不能再加了。下次是高级培训，高级培训有可能还可以，但是那个应用培训应该就不行了，要连那个传送带呀，还有摄像头啊那些东西。
要在公司给他们看的那些。
什么？
就是要在有公司有实物的给他们看的那种，对吧？应用
对，那种就好很多，不然的话就讲对着，因为下两个很多就是很多编程了嘛，你就对着 PPT 讲编程。
很难讲，其实他就是要给他做，就比较能容易懂一点感觉。
是的，是的，因为他有问题，比如说他有问题，哎，那个什么，脚本怎么用啊？我 PPT 上没有啊，对不对？
是的。
我连着那个机器的时候，我就跟他打开那个地方，跟他说，哎，用这个就好。
直接给他看。
对，所以到时候就辛苦哦，辛苦不少。之前为什么那个调休半天呢？是因为之前是真的很辛苦，6点半就在那里整，可能去吃个饭聊聊天，然后回来调试那些东西全都要重新确认一下都是可以的，然后就10点多了。 然后休息一会，11点就开播。开播的时候呢，也是两三个人啊，一个人讲，一个人在演示，然后一个人回答问题。
哇，这种是真的很辛苦。
然后搞完之后就比较累的。但现在这2次呢，是我讲了那么多次最轻松的2次了。基本上这些都是因为这个都基础的，基础的就没有什么演示。
是，就是跟他们解释就可以了，纯解释型的感觉。
对，因为这2个都没有，基本上没有编程。基础，但之后就不是。
那这个怎么说？现在是挂在这里吗？挂到？
我觉得你可以写那些什么，这个挂没随便你关了也可以，没所谓的。我最主要你睡觉之前要发一发，睡觉前发一发那个什么
记录。
上次那个记得吗？群里面的那个。
哦，那个可以，那个没问题。
对，你要发一发，然后我建议是你睡之前发，这样看起来就比较晚。
可以的。
对，
那个记录什么的导出来要怎么导？
哦，我发现了，我发现这个这样，我直接 Ctrl+A 加 Ctrl+C 就把它全拷出来了。
哦 ，Ctrl+A。
我对着那个什么。
哦。
我吃的都是这样。
那你要不考一份，我看看，我学一下。
我已经考完发给你了。哎，我直接 share screen 就可以给你看了。
哦，
你能看到我的屏幕？
我看到，我也可以了，全部复制粘贴了，等于就是。
对对，Ctrl+A 加 Ctrl+C， 我已经发给你了。
我这里也存了一份。可以。收到。
然后你就编一编，对，编一编，主要是编一编那个，反正你记得的，你看。